Tonight I have a Samsung 50-inch plasma, and turn off the heat so I can hear myself think. Press the power button. We hear the note indicating that it's turned on. But we have no picture. This one's a pn50a530 S2F, sold under a pn50a530. It's from 2008. It's one of the early ones coming out of Mexico, from Samsung Mexico. We'll get the back off this unit and see what's going on with it and why it's not starting up. So as you can see, this is a Korean-made panel. It's assembled in Mexico, but the main boards and stuff in the panel, it's out of Korea. We'll identify the boards on this set for the people that aren't familiar. Okay, your power supply board here. You've got your Y sustain, your Y upper buffer, Y lower buffer. This is your A board. There's a couple of them here. You've got your X main, as Samsung call it, over there. You've got your main control board here. This is the main DSPs to control everything. And down here you've got the signal board, which has got the analog and digital inputs as well as the tuner. First thing I'm going to do before doing anything on this set is I'm going to check to make sure that it does not have any loose ground screws. We'll check all the ground screws first to make sure that we aren't looking at something as simple as a bad ground. I don't see any capacitors that have got the obvious telltale signs that they're blown. I've just done a very quick visual on this thing so far. I haven't actually done any tests on it. I'm just going to go around and make sure that there's no screws that are loose. So far we're looking in good shape. Everything seems to be nice and snug on this set. I'll check all the screws for looseness, and then we'll get in there with the meter and start measuring for voltages. Okay, I got the big light out again because it just makes a lot of noise. The first thing I'm going to do is I'm going to just power this set up. I want to take a listen and hear if I hear any of the circuits working. Plasmas do give a distinct buzz when certain circuits are working. So you can hear the X main buzzing and you can hear the Y sustain buzzing and stuff. So I'm just going to turn the set on now. Just take a listen and see whether we can hear anything. So the power's on. And we'll also check our health light down here, which is flashing at, in fact, both the lights are flashing, which is a good sign. I don't hear anything happening from either sustain board. So let's check our supply voltages and see if our supply voltages are correct. According to the panel, our VS is supposed to be 204 volts. So let's just check our VS here at the VS connector. And we see that our VS is only 8 volts. So we have a problem right there. We have no 204 volt VS supply. We'll check our VA voltage, which is supposed to be 57 volts, and see whether we have a VA voltage here. And again, it's only measuring at 8 volts too. So we know that the power supply is not starting, and that would be why this set's not working. But why is the power supply not starting? That's the question. Is it in a shutdown state because there's a problem, or is there a problem with the power supply? Let's take a look and see what's going on. If we get real close to the power supply, you can probably hear that hum. So the power supply is making a whining noise. So I think we have a problem on this power supply. Something is drawing too much current, or maybe we do have a bad filter on here and it's just not showing as a pop top. We'll disconnect the VS and the VA supplies and check and see if our voltages come back. Okay, I've got the set powered up and I've got the sustain boards disconnected, and as you can see, we still don't have any voltage. We've got 14 volts on the VS and the VA is down at less than 1 volt. And this thing is still squealing. So I think it's pretty safe to say that there's a problem on this power supply. Let's take the power supply out and take a look at the power supply itself. So I'm working on this with the ESR meter, and I'm just going and measuring a few of the capacitors, and one of the caps that I've come across on this board is right here. It's C5 or 50, sorry, CS814 looks like. It's on the board right here between the little transformers. We look at it here. 1000 microfarad 10 volt. A 1000 microfarad 10 volt capacitor should be no worse than 0.12 ohms ESR. And when we put the meter on this one here, it's coming up at, well, this is measuring 0.3, so it's a little bit up. And there's one other one that I measured on here, and it is gotta find it again. I think it was this one over here. .47 microfarad at 50, and it's coming up at 0.8. 47 microfarad at 50 should be about 0.5. So a couple of them that are just a little bit high. I'm going to change these two capacitors out, and we'll try this thing and see if it fires up. Now the customer that owns this did tell me that if he leaves the set turned on long enough, it will start. So that is telling me that a capacitor is probably charging up as it's sitting, and it starts to work a little better. So we'll change a couple of the ones on, all the other ones test good. These two are just a little bit over the limit, so let's change these out and see what happens. So we're just going to remove this other cap. I've already changed this one over here. I'm just going to remove this one from the board. So this is the 1000 microfarad at 10 volts. I've got a new one here. I'm going to put a 1000 microfarad at 25 volts in. While we're at it, I'm also going to inspect all these surface mounts just to make sure there's no cracked connections on any of them. And we'll give the board a good once over, looking for any problems on any of the pins here, on any of the components. Of particular interest is connections around some of the larger transformers, because these handle the bulk of the current for the set. So give the board a once over. Make sure there's nothing that's obviously cracked or burned. Also, when I'm working on these boards, I always give them a good inspection. Use my little TV camera lens, give it a really good inspection, and also I do an inspection with the video camera here. As you can see here, we got some cracked connections around here on these diodes. And a good rule of thumb whenever you're working on any of these power supplies, in addition to looking for bad capacitors, anything that's mounted on a heat sink, such as all these transistors, diodes, MOSFETs, etc., anything mounted on a heat sink, inspect the pins very, very closely for broken solder connections. The big problem you have with this is you've got aluminum, you've got different types of materials, aluminum, copper, plastic. They all expand and contract at a different rate. and this can cause stress fractures on the board. And as I was looking at this one here with my TV camera lens here, I noticed that these connections here are all broken. You can see it on camera there. If I zoom the camera in, you can see this one's bad here, this one's bad. These are all bad. So I'm going to go through and I'm going to resolder all of these connections, and we'll put the board back in and we'll see if that fixes our problem. Good chance that that's what's wrong with it. There was a couple capacitors that I've changed on here because they had a little bit of ESR problem. They were starting to go bad, but I think our problem is probably bad connections more than anything. So changing the caps is just good measure, just so that it prevents future problems. Because if the ESR is starting to rise on a capacitor now, it's going to continue to get worse. So I'm going to go through and I'm going to resolder all these connections. We'll put the board in and we'll see what happens. But I bet you there's a good chance that that's going to fix it. These diodes that I'm resoldering here, these are the ones right on the VS supply, which is my supply that's low. And these are the ones that rectify the power coming off the VS secondary here. This is our VS secondary, these terminals here on the transformer. These rectify the AC coming off the transformer to DC. It's stored in this capacitor here. This is our main VS supply, which powers the panel. So it's more than likely just these connections that were causing the problem. But I'm going to go over them all the ones that look like they're suspect. I'm going to go over them all and make sure that we get this problem solved. Okay, as you can see, I've resoldered these connections here on these diodes now. These ones were bad. There was a couple of other ones further down the board, whoops, that also were suspect, so I did them as well. Let's put the board back in the set now and see if we fix the problem. Well, interesting, because I powered the set back up, and now I have my VA supply. It's 57.2 volts, which is what it's supposed to be. My VS is only coming up at 8.4. So we still have a problem in the VS supply, but I've got one of the supplies up and running now. Let's go back and look at the VS supply and see why it's not starting. Because I still have a problem with this power supply, what I'm going to have to do is I'm going to have to power the power supply up out of the set. I have to force the power supply on. I'm going to have to add a couple of resistors between either 5 volts and the power control pin, or ground in the power control pin. To prepare the power supply for work, I want to make sure that I don't cause any short circuits due to any contamination on my carpet here. So I've just got the power supply sitting on a piece of paper. This is only just for insulation. That's just in case there's any solder splashes or anything on my carpet that could cause a short circuit. Now over here on this connector, you'll see a couple pins that are labeled VS on and PS on and ground and DC 5.3. When I apply power to the power supply, I should have voltage on these standby pins with respect to the cold ground. If I apply power, we'll notice that we have our little standby light here indicating that the power supply is running. The standby supply is running. And if I measure between the PS on and ground on my meter here, I don't know if you can see it or not, let's just zoom the camera back so that you can see this. If I measure between the PS on and ground, and I've got my meter grounded here to the heatsink, I see that we've got 4.4 volts. So that tells me that that pin has to be grounded to turn on the power supply. So I'm going to put a pull down resistor between ground and the PS on. That way that will start one of the power supplies. It won't turn on my high voltage because that's done with another pin over here that I'll also either have to pull up or pull down. But we have to get the main power supply. Just the standby supply is now currently running. We have to get the main power supply to turn on. So that's done with a pull down resistor between PS on and ground. So by placing 2 resistors, and I'm just using a couple hundred ohm resistors, it's not really critical. This is just the pull down resistors between here, the first pin here on the end, which is called PS on and ground and PS on and ground. So they're both labeled as PS on. So ground both of these pins, and as soon as we apply power to the unit, it should try to start up. So now we can check for our voltages. So I'm just going to reground my meter. We'll turn on the power supply. Now again, I'm working through an isolation transformer, so before any get flames going here that I'm not working safe, I'm actually working very safe. This entire unit is on an isolated supply. Just going to move any cables out of the way that could cause a short circuit. Everything on my bench is isolated. So when I do use the scope on here, again, everything is isolated. So turn on the power, and now the power is on. And if I go over to my VS here, you should see some voltages here. Where's my VA supply? I think we should have our VA supply. There's 5 volts there. I was looking for there's my 57 volts for my VA supply. My VS supply should be here, and I'm not getting any voltage. There may be one more point that I have to ground to turn on the VS supply. I'm just going to take another look at the board here. There is one more connection I have to make. It's VS on, and it is currently at ground, so that one needs to be pulled up to 5 volts. So I'm going to put a pull-up resistor from VS on, which is the second pin here from the end, down to the 5 volt supply. So I'm just going to put another resistor in on the other side here, and that will turn on the power supply for my VS supply. Right now I've got all the supplies running except for the VS. It has its own connection to turn it on. So now I've got it set up. I've got my resistors in place. I've got, if you look down here, I've got 2 pull down resistors. This is for the PS on this connector, and the PS on this connector over here. And then another pull up resistor, which takes 5 volts over to the the VS on. So now this should start all of my power supplies up. So we'll apply power. And what do you know? I have my 206 volts on the power supply. So my power supply is working. Why wasn't it working in the TV? I've got my 206 volts, and I've got my 57 volts. So what it gives here? It's the power supply is working out of the set. When it's in the set, the power supply is not working. So what do we need to do? We have to look at what's controlling the VA or the VS, which is controlled through here. Now that's controlled from the control board. So maybe we have a problem on the control board. Let's just unwire this again, and we'll put it back in the set, and we'll monitor the VS line and see why, because it's only coming up to 8 volts. So something is not right here. But the power supply appears to work when I've got it out of the set. It's just not working in the set. So let's get it back in the set, and we'll check some of our control voltages coming off of the main control board. Okay, the very fact that my power supply works when I've got it out of the set and I force it on with resistors, and it does not start when it's in the set, is telling me that we may have a problem on our Y sustain board, because as you already know, the control board here is what's turning on the power supply, and it's doing a self-test of the Y sustain board to make sure that the Y sustain board is ready to start. If during the communication handshake, when the main controller board is talking to the Y sustain board, if it doesn't get an A-OK, all systems are ready to go, it's not going to turn the power supply on and supply power. So we have to look at the Y sustain board. Maybe we've got a broken connection on here. That's probably one of the most likely things. It's going to be a cold solder connection. I don't see any capacitors that are blown. The owner of the set said it works intermittently. It would work. It was just taking longer and longer to turn on. It could be a capacitor, but it could be also something like a solder connection. So I'm going to pull the Y sustain board, and we're going to look at that one and see whether that may be why our power supply is not starting. And of course, to remove these ribbon cables, just flip them up, flip the little lever up like that, and then the connector comes out. Power cable for the top, just push the little catch in. We'll pull the screws and pull the sustain board out. Okay, we know that this set has a problem. It's not turning on the VS supply for the power supply. I've got my scope hooked up to the VS supply toggle. This should go up to 5 volts when the control board tells the television to turn on, but it's not. And what I don't know is why it's not turning on the power supply. It could be a failure on this control board here, which is very likely, or it could be a failure of any component on any of the other boards. Could be on the Y sustain, could be on the X main. Don't know, because the control board talks to all the rest of the circuitry. And if it's getting an error from any of the other boards, it's not going to turn on the set. Now, the customer told me that it will turn on eventually if it sits. It's taking longer and longer, so it may be a thermal problem. So I'm just going to take my good old heat gun, my hair dryer in other words. I'm just going to put some heat onto these chips here and see whether we get any action happening here, because it could be a cold solder connection under one of these BGA chips, and when it sits for a while, it heats up enough to expand the circuit board and makes a connection. So we'll put a bit of heat on here and see if that makes a difference, see if the set will come on. Nothing found there. The next thing we're going to examine is the X main board for any type of connection problems on here. Again, the power supply is being kept shut down by the control board or the logic board for a reason. And it's either going to be a component that's failed on either the X main, the Y sustain, or Y main, or the Y buffers. I looked at the Y main yesterday, didn't see anything obvious on that, no cracked solder connections, checked the diodes and the transistors on there, couldn't find any obvious shorts, fuses aren't blown. So we'll look at the X main, also known as the SS board on Panasonic. So we do have to remove these ribbon cables before we remove all the screws. Just open them up and the ribbons slide out. These are just a solid copper connector, and what these are is these are the common drivers. This is where all the current for the panel goes through this board. This is what affects your panel brightness. So they are quite a common problem. I've had that fail on LG and I've had it failed on a Panasonic. The LG said I had to replace the hybrid module on it, and on the Panasonic I had to replace a couple parts that failed. I think there was 4 parts on the Panasonic on the SS board. So certainly these are a trouble spot. Of course, just like the Y sustain, they do put this heat sink compound on. This is to drain away high temperatures from the solder connections. They only put it on half the board though. These ones here, there's nothing on this side. We're going to take a close look at these connections and make sure there's no broken connections here. Now I am convinced that we do have a logic board, possibly the logic board problem on here. And the reason I'm convinced that is because the TV will eventually turn on. And when it does turn on, these 2 lights here that are flashing will flash at a faster rate, and this one that's solid turns out on the logic board, and then the set turns on. The set is turned on now, but there's no picture, there's no 204 volt supply, and the 3 volt trigger, which turns on the 200 volt supply fed from the logic board, is off. we'll leave this thing turned on. I'm going to time this thing and see how long it takes. It will eventually turn on because I have had it turn on. And I'm thinking maybe we have a cold solder connection or something on the logic board, and when it heats up hot enough, the connection gets made. But so I'm going to try and localize it with some cold spray, see if I can get the thing to shut down again once it does turn on. I have had it on. It will turn on by itself. So that proves that there's no problem in any of the sustain boards and the buffer boards. Even though I already tested the buffer boards, there's no shorts on the buffer boards. I tested all the semis. All the semis tested good. So I know there's no problem with the set itself other than it won't turn on. And then while I was just sitting here monitoring it, all of a sudden I noticed that this light wasn't flashing. I went around the front and the set was on with the Samsung logo bouncing around on the screen. So I'm just going to let the thing sit here until it comes on again, and then we'll start hitting the thing with cold spray and see if we can shut the thing down. But I'm convinced we have a problem, and I'm pretty sure it's going to be on one of these chips here. Maybe one of the BGA chips has a bad connection. Which one? Good question. I guess the best thing to do is just to heat the whole thing up and try and reflow them all. But it's going to be a tough one to try and nail this down just because of how intermittent it is. And when I turn on it, it's going to sit here for probably 10 to 15 minutes before the set actually turns on. But once it's on, it's running. So it's just a matter of figuring out what's causing it to turn on slowly. It's gated. I'm convinced it's something on this board here. Okay, I've noticed that this third light now has just started flashing. We still don't have voltage yet, but this one was solid before and it started flashing. Now, when the set comes on, that light should stay out when the set finally does kick in, but something's going on now. It's starting to do something. So, as we can see, the third light stopped flashing. It's gone out. We have 3.2 volts now on the VS on supply, and if we move around to the front of the TV, we'll see that the TV is running. As you can see, the set is now on. If I power it down with the power button, set will turn off. Press the power button to turn it back on. Will it or will it not turn on? Hit the power button, we'll get the note telling me it's on. But no picture. We move around back to the back and we notice that our VS supply is off and this green light is once again solid. Let it sit for a period of time. The set's going to come on. I'm thinking it's probably something on the logic board here that's gone bad, and after it sits for a while it starts working. We're going to maybe try reflowing the connections on these BGA just by setting it on a flat surface and letting it bake with my infrared light. I'll do all the chips and just see whether that solves the problem, because I'm pretty sure that our fault is on this board. The common thing that's preventing it from going is the main controller, the CPU board. That's the brains, that's what controls everything. We've got our panel processor here to process the picture. It takes the low voltage differential signaling from the signal board, and it does all of the signal processing to drive the panel. It also controls the power. So there's no drive heading out of this to the sustain boards. There's no power to head out to this to the power supply. The problem is going to be on here. So I've got my little reflowing jig set up. I'm going to turn on the lamp here. I'm going to let each of these chips bake for a while. I'm running this lamp at more than 120 volts. I'm running this lamp at about 140, maybe 130 volts. So it's going to make it hotter than a normal, I've got on my Variac, it's going to make it hotter than a normal GU 10 50 watt lamp. Of course it'll shorten the life of the lamp, but I don't care. Lots of these bulbs are cheap. I'm going to let this run here. It's going to get it hotter here, and we'll let this thing reflow for a few minutes. We'll do each chip, and as you can probably, I don't know if you can see it or not yet, but even just this little bit of time here, I'm already getting it bubbling up here good. if anybody had any question, can you get enough heat out of a halogen lamp to reflow solder on a circuit board? Yes, you can. I've used this technique a few times and it's always been successful in getting circuitry working again, and so far I've had pretty good luck with it. Here's a prime example. You can actually see underneath this chip, you can see the actual little solder balls that are underneath there, and this is what happens is these connections, these little balls of solder, when they heat it up at the factory, sometimes they don't get it hot enough, and it doesn't connect. It doesn't make a good connection, and it cracks. One more here to cook for a bit. Now I use the light bulb to heat up the smaller ICs, but obviously a 50-watt light bulb isn't going to give me enough heat to reflow one of these big BGA chips, so I'm going to use a heat gun. We're just going to set it on low setting, and I put some heat shield tape around here. This is to keep other components from being dislodged. And I'm just going to heat this board up here for a few minutes, just in a circular motion over top of this chip. I'll do the same for the other chips as well. I'll do them all separately here and see if we can get enough heat in here just to reflow, just in case it is a connection problem. Because the way that this set is acting up, I think something is triggering either a temperature shutdown or something. Something is triggering a shutdown circuit that's timed by this board. So I'm just going to do this for a couple of minutes. This should put enough heat in to reflow any of the solder below in here. I'm just going to keep moving the iron or the heat gun. I've got it set on low here. We'll do this for a couple of minutes for each of the chips and let them cool and see whether we can reflow any solder connections underneath here that may be a problem. Okay, board back in, hit the power button, and we get our 3 volts. You guys can't see that. 3.2 volts immediately. Set turns on, and we've got our 2 blinking lights and no third light. We should have a picture on this thing. What do you know? Plug the signals in. We have a picture on this set. So I don't know which one of the ICs that was bad, which one was causing it, because I reflowed all of them with my infrared light and let them all bake for a while and put it back in. But our problem on this set was caused by one of these ICs. Poor solder on one of these ICs. That's the only thing I did on this set after determining the problem was on the control board, was reflow. I tried resoldering these ICs first with the iron, all the surface mounted ones, put it back in. It made no difference. I took it out and I just let the light heat up these ICs here. And that was all that was done. Put it back in, the set runs. I'll turn it off and on and run it a few times now and keep our fingers crossed that we got this one nailed down.